I want to welcome you to this chapter, and in this chapter, we're going to be looking at the introduction to virtualization features. Previously, we have discussed in the previous sections what cloud computing is, and we have come to understand and appreciate that it is a service delivery model, whereas virtualization is a technology. It is a virtualization technology which we build on to come up with our cloud computing kind of service. That's why virtualization is the main technology in cloud computing. And specifically in this course, we are looking at cloud computing era 1.0. And now we want to understand, yes, you're telling us that we are looking at virtualization, but what are some of those features that we are going to benefit by using virtualization? And we're going to be looking at some of those things and also be able to understand some of those different characteristics. We noticed earlier on in the previous sections that we have our traditional resources, our traditional IT resources, and we can literally also virtualize almost all the resources that build up the computing, computing gadgets or computing resources. Firstly, we looked at the introduction to cloud computing. We went ahead and looked at the introduction to compute virtualization. And when looking at compute virtualization, we looked at three main things as part of compute virtualization. We looked at how we can be able to virtualize a CPU. We also went ahead and looked at how we can be able to virtualize our memory, our physical memory. We also went ahead and see how we can be able to virtualize our input or output devices or processes on our computer. Some of them being like the network interface card, our disks, buses, etc, etc. With memory virtualization, also went ahead to see how can we be able to virtualize that memory so that virtual machines or things that are working inside a hypervisor can basically benefit on the same physical resources that we have. Here in virtualization, like we said earlier, what we're trying to focus on is resource utilization. We want to be able to utilize our resources. We have bought hardware resources. Let's say it's a physical server and we have bought it and installed it somewhere. Instead of us installing one operating system on these physical servers, and we're only using 20% of the hardware resources, and we have or we need to get another machine. Instead of buying another box there, and we're going to probably use 10% of those physical resources, why don't we virtualize this one machine so that we can reuse these same physical resources to cater and have us run more than one virtual machine or more than one operating system in this one physical machine, and that is virtualization, and this is what we are looking at. So we looked at compute virtualization. We also went ahead and looked at what was the next one. People who are attentive.
Storage.
Okay. Before we looked at storage, we looked at something else, but I'll also put here storage virtualization. We wanted to understand, yes, we have looked at these resources which you can virtualize, and virtual machines can use those resources. But now, how are virtual machines going to, access the information they are going to keep? Even if they access that information, how are they going to store that information? How are they going to utilize the underlying storage resources in our traditional IT environment? So we looked at some of those things. We said that we looked at storage in a non-virtualized environment and also storage in a virtualized environment. We also went ahead and looked at centralized kind of storage, and also went ahead and looked at distributed storage. But most importantly, when we're looking at storage, also looked at some of some key concepts like RAID, and also we looked at some concepts like replication. When we are looking at RAID, we said there are 7 categories. There are 7 major types of raiding, and we focused on 4 types of raiding that we looked at in that chapter. We looked at which raid and which raid and which raid?
RAID 0, RAID 1, 5,
6.
5 and 6. We looked at these things. Also, when you're talking about centralized storage, we looked at some things that we can look at. We either looked at NAS and we also looked at SAN. Yes, I was just giving basically a brief recap of how far we have been moving. So after looking at storage virtualization, we went ahead and looked at network virtualization. We went ahead and looked at network virtualization. Yes, we have understood we can now store our files. Our virtual machines can store files and access the local disks or the disks in our traditional IT environment. But now, hey, how are these machines going to be able to communicate with their virtual machines, or even to communicate with physical machines, or even communicate to external networks? We know that it is a box here. We have virtual machine 1 and 2, and there are no some kinds of wires that are going to combine them. How are these machines inside this box going to be able to even access my external network, or how are they even going to be able to communicate with each other? We also looked at quite a number of things, but we said that virtual machines have some kind of virtual devices that they use also to communicate. We looked at a virtual switch, and also went ahead and looked at a distributed virtual switch. We also went ahead and noticed that the virtual machines actually have also virtual network interfaces. For those who are attentive, just a teaser question. We went ahead and said that the link that connects the distributed virtual switch to the physical network interface card of our physical server, what type of link is that, and how do we call it?
An uplink.
It's an uplink.
It is called an uplink. You guys are brilliant. So these are some of the things that we looked at. So we have looked at all these things, and we have tried to understand and appreciate their importance as far as virtualization is concerned. But now, why I don't think I need virtualization. Why do I even need virtualization? What extra features do I get by using virtualization? And we want to look at some of those things today. So having attended the previous courses about cloud computing, you may already have a good understanding of virtual machines, and I believe you have a good understanding of virtual machines, because previously we went ahead and created our VMware virtual machine together, and on that virtual machine we went ahead and installed Ubuntu. And the resources they use, we have looked at these resources, and you have told me the resources already, right? The compute resources, the network resources, the storage resources, the virtual machines use those resources. So this chapter focuses on when and where we could need to use virtual machines, and what virtualization features virtual machines provide to us. Upon completion of this course, you'll be able to understand virtualization features. You'll also be able to understand where and when virtualization features may be used. So, quick question. What are the benefits of virtualization in your understanding? You can just quickly tell me. So mic check and go ahead and say it.
Mic check.
Go ahead.
Yeah, resource utilization.
Resources.
Mic check.
Resource utilization, yes, please.
On cost management.
Cost management.
Fast.
Yes, please.
Mic check. Quick access.
Quick access.
Quick access.
Access management. Yes, please.
Mic check.
Yes, please.
Resource pooling.
Resource pooling, or putting resources together. Okay. All right. And you are all right and correct. Someone wanted to say something?
Yes, faster deployment of resources.
What is what?
It allows faster deployment of resources.
Oh, yes. Fast deployment of machines, that I can go to the machine which I've already, created here in my VMware. Did my VMware start? Yes, I can go into the machine here, my Ubuntu machine which I created in my VM, and I can go ahead and I say, you know what? I want either to make copies of this, or I want to go ahead and replicate it, or I want to go ahead and, create different instances of this machine. What else can I do with this machine? I can go ahead and power it on. I can go and copy it on another machine. I can easily go ahead and manage it because there's no corresponding disk. I think Every time you power on the virtual machine, do you want to try and connect to the virtual disk? No. I changed some few things. I'm hoping I did not change it. Ever since we installed it, I've never bothered to use it, but we're going to look at some of those things and details later on and see how best we can see. Also, are you seeing this? There's a point where we're going to come and talk about it. The VMware tools. VirtualBox calls it guest additions. Yeah. Have you seen them? The VMware tools. VirtualBox calls them guest additions. There's somewhere we're going to be able to talk about them later on. So you can install these guest additions or VMware tools for you to be able to even use your a virtual machine even better to perform other functionalities like we're going to discuss later on, trying to understand some of those virtualization features. So we're going to look at those things later on and in detail. So you are all correct. These are some of the benefits of using virtualization. But hey, I want us now to think in the direction of now cloud engineers. We are not thinking of the direction of the end user. Yes, true, many of those things are benefits to us as cloud engineers, but most importantly, we looked at benefits or characteristics that by using virtualization, we are able to partition our hardware resources, isn't it? To partition our hardware resources, and we can partition them and assign them to different virtual machines for use. What are some of the other ones that we used? I've just given you one to make sure that you all remember. There were 4. We looked at one, the second one, the third one. Yes, please.
Isolation.
We also talked about isolation. And by isolation, what did we mean?
Check.
Yes,
I
go
think
ahead.
a fault in one virtual machine doesn't affect the whole cluster.
Yes, that our virtual machines are independent of each other, and a fault in one virtual machine does not affect the functionality of another virtual machine. So let us also go ahead and look at the third one. What did we talk about?
Encapsulation.
We talked about encapsulation. Very good.
Encapsulation, this is whereby a group of hardware have independent files.
A group of hardware, yes, independent. So it's going to get our hardware resources and bundle them into some kind of logical kind of files. Our virtual machines are going to be stored into some kind of encapsulated files and folders, which can easily be copied, which can easily be deployed, which can easily be migrated from one machine to another. And thus you are seeing, by looking at these characteristics, we are achieving almost all the benefits and advantages that you have told to me. Also, I want to look at the fourth one. What was the fourth one?
Mic check. This is a hardware independence feature.
Hardware independence feature. With hardware independence feature, this means that our, virtual machines are not bound to our hardware. Through using isolation and through using encapsulation, we can easily just copy these files and put them on any other machine. And as long as we have our hypervisor, we can run it, we can manipulate it, we can do just like you saving your Word file on your Microsoft Word file from one computer and opening it from another computer. And yeah, as long as you have Microsoft Office, Microsoft Word, you are able to modify and play along with those features. So these are some of the features and those are some of the benefits. So as you can see, virtual machines, people can use them in all sorts of different, so many different people from the bank, the places we are working. All those people can access virtual machines and they can use them to, achieve their desired goals. So, but these people are using these virtual machines, and like we have been asking ourselves, what do I get by using virtualization? Let us look at some of those features from a perspective of a cloud engineer. So we are going to look at these features in 2 categories. We're going to look at them at a cluster level, and we're also going to look at them at the virtual machine level, right? We're going to look at them at the virtual machine level. We have talked about the cluster before. What is a cluster?
It's a group of nodes.
Yes, please.
A cluster is a group of computers that like collectively provide resources for the users, like compute resources, storage, and network resources.
Very, very good. So a cluster is your group of hosts, your group of computers, your group of physical servers. You put them together to form one cluster. And this cluster, its entire purpose is to provide collectively, all of them to provide resources for the users, including all the resources that our brother has told us about, the compute resources and network resources. And we have talked about all those resources before, the resources we can get from compute resources. And we want now to look at what are some of those benefits, what are some of the features we gain by using virtualization at a cluster level before even we focus and get onto a virtual machine. What happens in the real life environment? People with big data centers, they have clusters, they have servers inside those clusters, right? We have one cluster and it is a band of virtual machine 1, virtual machine 2, virtual machine 3, physical machine 1, physical machine 2, physical machine 3, physical machine 4, 5, 6, and all these machines are put there to provide resources, the CPU resources, memory resources to the different virtual machines, which we can create and put on our and provide to our virtual machines. So let us look at the first feature, and which first feature is going to be called high availability. So with high availability, it is going to help us that to ensure that our virtual machines are readily available, and and we are going to increase on reliability of our virtual machines. That in case one physical server dies and these virtual machines were on this physical server, we have virtual machine A and virtual machine B, because our our virtual machines are stored as configuration files and disk files. Which feature is that? Which characteristic is that?
Encapsulation.
Encapsulation. Because of the power of encapsulation, and our virtual machines are stored as, configuration files and disk files. The disk files are usually stored on a shared storage, and the configuration files are stored on these computer nodes, the CNAs. This one's also another name. They can be called CNAs or physical hosts or hosts or nodes. They can be called all those names. So that, and the configuration files are stored. What happens there is that if this node 1 or CNA1 or physical server 1 fails, then the virtual machine or the hypervisor or the manager can now use the VRM or vCenter. If you're using Cisco, or if you're using Huawei, you can use VRM, and they are going to rebuild these faulty virtual machines onto other nodes, right? Maybe carry it there, and they're going to build it onto other nodes. The end user who is accessing these resources will even hardly notice that there's been a failure on the networks, on the virtual machine, or even that this physical server actually is dead. They won't even notice. For them, they'll continue accessing LMS, do the assignments, and they are not aware that actually there's been high availability. That why they are saying that it is highly available is that because we have other nodes in our cluster which are running, and in case one fails, these guys will come in and take charge, and the virtual machines will be built on one of those virtual machines. So it helps us in case there's a fault to migrate our virtual machine, to lively migrate our virtual machines onto other functioning hosts in our cluster. And this helps us to create or bring about high availability. Just like you can see in this illustration, we have our physical server here, our CNA node 1, and it has become faulty, and we have our virtual machines here. Let's say this is our application server, and let's say this is our backup server, and we want to make sure that our backup server is running and our application server is running. So at the end of the day, our end users here are not do not be interrupted in accessing our resources. So what happens when this machine fails? Because of the policies we have configured, the virtual machines will, be migrated from it onto other functioning hosts in our cluster, thus achieving high availability. And this is what we are calling high availability. So during high availability, you need to be in position to detect the hosts which are working and the hosts which are faulty, and also be able to manage virtual machine startup failures. Sometimes the host may be okay, but the virtual machine itself may be able to fail to start. That's why in Fusion Compute, Huawei's virtualization product, they have a mechanism they use to detect so that they are able to know which virtual machine, which host in a cluster is either still alive or which host is now faulty. They use something they call the heartbeat mechanism, and this heartbeat mechanism, it is between the CNA host and the VRM to check whether the CNA is still active. CNA means a physical server. It can mean a host. It can mean a node in our cluster. So they use that to be able to check and see if the host is still available. Yes, someone
Hello,
was
Mr.
saying
Sandy.
yes, please.
Yeah, as you are talking about the heartbeat mechanism, so is it same as we have in firewall? Like when we just configuring the VRRP, so we just enable the, or hold standby, we just enable the, that heartbeat interface over there. So same thing.
Romeo, you have a feedback on your end. I think you're connecting two devices. Sadula, I didn't really get you very well.
Actually, my question is that, yeah, actually in between the talking, so there is an interruption. That's why I wasn't able to complete my questions.
Okay.
So can I ask?
Yes, you please go ahead and ask. But I want us to minimize so many questions. Maybe you can bring them at the end, but you can go ahead and ask.
Okay. Next time I'll be take care of it. So my question is that as you talk about the hardware interface, so it is same as that as we have in firewall, when we configure the host standby.
Yes, it's almost working the same way like that in a firewall. It like the heartbeat rate, the one we have in the firewalls. Its main role, this one basically relies on hello packets that are sent, but I don't want us to discuss security here. But here we are saying we also have this mechanism and it has different timeouts. Remember the hello packets in security on the firewall, they are sent every after 1 second. Here we are looking at 30 seconds, okay? So they almost work almost the same way, but here we have every after 30 seconds to be able to detect if this virtual machine is either working or it is failing. So if the terminal or if the host that is connecting to our VRM sends out and receiving the heartbeat packets every after 10 seconds, and if the total wraps up and we have over 30 seconds and 10 seconds of total fail out, making a total of 13 seconds, then our VRM will be able to detect it that as per our heartbeat frequency, one of the one of the hosts in our cluster is not responding. Therefore, let me rebuild and reconstruct these virtual machines from that node to onto another node. And also this is subject to what you can configure in as an engineer. Depending on what you want to achieve, you can choose to configure different settings on your system. I didn't get your other question. Your other question was? Asadula, your other question was?
No, I have got the answer. Thank you. Can you hear me?
Satisfied?
All right. So allow us to move.
You can move, sir.
Yes, please.
let's continue.
Okay, we continue. So this is what we are calling high availability. The next feature we are going to look at is what we're going to be calling load balancing. And we want to be able to understand what is load balancing. Why is it even important? Load balancing is a cluster technology that distributes the loads evenly to multiple network devices such as servers, firewalls, or even links. And this helps us to improve processing capabilities and ensure high service reliability. If you notice, if you all access services from one server at the same time, we have an issue. People will try accessing it and you're getting either 504, or maybe it will not be responsive, or it will become extremely very slow. You all agree with me. So with virtualization, it gives you another feature of load balancing where you can be able to distribute that load evenly. Even when you have your CNAs in here, CNA 1, 2, 3, 4, you can be able to distribute the virtual machines that are created on your cluster and evenly distribute them accordingly. This helps us to have high performance. It also helps us to make sure that our virtual machines are reliable because the load is going to be evenly distributed, and it's also going to be, it's going to enable us to, have a quick scalability. We can move and distribute the load onto other hosts in the cluster, and then we can be able to either remove that one and add resources, or even add other CNAs here to make sure that our load is balanced. As you can see this picture already here, it is a bit unfair for one of these virtual machines, right? One of these physical servers. Some physical servers or some CNAs have lightweight, whereas others are, are shocking on quite a number of virtual machines created on them. We have our virtual machine 1, our physical server 1, physical server 2, physical server 3, and physical server 4. Which one of these is suffering a lot as far as load? Which one is loaded most?
Server 3.
This is server 3.
3. And probably physical server 3 is not happy, right? It is not happy because it has used its resources and maybe it has clocked over 70%. And it's not happy, and yet this guy has only maybe used 10% of the resources. So through using load balancing feature of virtualization, automatically these virtual machines can be migrated onto physical servers which are having lightweight and evenly distributed to those physical servers. That's at the end of the day making physical server 3 happy. Does that make sense? So this is what we are calling load balancing. So it can be able to balance the load evenly and distributes it across multiple devices on the network. So this is what you're calling load balancing. The load threshold can be specified by a system administrator. You can be able to specify if my load on a given server reaches maybe 70%. Please just check and see in my cluster which server has below 70%, and move that virtual machine and migrate it onto that server. So they can be specified by the administrator or even defined by the system. And in Fusion Compute, if the CPU and memory usage of a host exceeds 60%, then VRM will go ahead and migrate the virtual machines on the hosts or to other hosts. So, but before migration, the administrator can set an automatic migration task, and alternatively, the administrator can manually perform the migration after receiving a notification. So when you receive a notification, you can go ahead and, please check on my virtual machines. I have clocked 60%. And then you can go ahead and manually choose to migrate them, or you can set a task that whenever it hits 60%, they go ahead and be migrated onto other things. We talked about VRM. People who are attentive, what did you say VRM is? Oh, we haven't talked about it.
Virtual resource manager.
The virtual resource manager.
Resource management.
Good. So let us look also at another feature, and this feature is what we are going to call resource pooling or scalability. So scalability, like you hear the word scalability. like you hear the word scalability, it is to enable us add more or remove resource or remove resources from a cluster. So we have our virtual resource pools here, and we have put physical server 1, 2, 3, and 4, and they're all providing these resources. They're providing storage resources, they're providing CPU resources, memory resources, and we have come up with our virtual pool of resources. And once we create a virtual machine and we assign virtual machine, you're going to use 2 GB of memory, and you're going to use, let's say, 1 core of our CPU, and you go ahead, you're going to use 4 GB, and you're going to use 2 cores, and you go ahead, 2 GB, blah, 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 and set and configure and create your virtual machines. After configuring your virtual machines and you start them up, these virtual machines are going to reclaim what belongs to them. Because you have assigned them these virtual resources, and they have gone. And in your virtual pool, you don't have enough resources. And let's say even the traffic increases or the load increases, and you need to add there more resources. You agree with me that traditionally, if you had your laptop there and you want to increase resources on your laptop, you agree with me, you want to add and increase, let's say, your memory. You had your 4 GB RAM, but now you're opening Chrome, and you told me Chrome is consuming a lot of memory. You're opening Zoom, and it is asking you for memory. You get money, and you decide to buy yourself an 8 GB chip of RAM, right? And you want to install it. But then you are on to a Zoom meeting and you don't want to close it out, or you're even doing a Huawei exam and you don't want to close it out. But the system is asking you to increase resources because it has become extremely slow and unusable. Is there any way you are going to increase this memory from 4 GB to 8 GB minus you switching off your PC, losing your exam session and opening it and removing the chip and putting it there traditionally?
No.
There's no way. You have to switch it off, power it off, open with screws, and then add your memory. But with virtualization, we can actually, even when things are running, we can go ahead and add more memory to our virtual machines. And we can do this at a cluster level. Because we're looking at the cluster level, we can go ahead and just add more, or power off one of these machines. Remember, these virtual machines will not be affected. Even if there are virtual machines here, we shall use some features to migrate them to other live working hosts in our cluster. Which features did you say we can use? The moment we power on this guy, we shall have high availability taking place, because we shall assume this host is faulty, and then these virtual machines which were here will be migrated onto other hosts in the network. Still also, when we go ahead and open this machine, even if we have powered it off, and we go ahead and add more, maybe add another disk of 2 TB, we can also go ahead and add more memory. Now, when we power it on, it will add these other new more resources onto our pool. But that is also one way. But the best way is actually you just getting another virtual machine, another physical server, and placing it and configuring it on your cluster, or even adding more. And all these guys are now going to give you more resources, like you can see in this illustration. This guy is not happy. The resources are now being used by our virtual machines we have created over here, but he needs more resources. What you're going to do, just get 2 more, get more server A, server B, put it there, configure it, add it on our cluster, and boom, they're going to provide more resources. And our, all the resources are more than enough. Our virtual machines are, happy. We can even go ahead and create more virtual machines and, assign them more resources, or even go and open these virtual machines and add them more resources. This is what they are calling scalability, minus interrupting the most important things, minus interrupting the services at the end of the day. The users are still enjoying. They have uptime guarantee. They're not affected in one way or another. But for you as the engineer, you're busy there diving into machines, removing them, adding things there. But then there's no interruption of service. We also want to, this is what they're calling easy scalability. So we want to look at another feature which are calling memory overcommitment. Memory overcommitment, sometimes they call it multiplexing. depending multiplexing. So we want to look at memory overcommitment. With memory overcommitment, basically, it allows us virtual machines to use more memory than the total physical memory of the physical server by leveraging on specific technologies to improve on our virtual machine density. For example, here we have our hypervisor here, right? It is 4 GB. Our physical machine has 4 GB of memory, which we want to use. But for example, to install some of the Linux operating system, let's say Ubuntu, it requires a minimum of 2 GB. And once you create a virtual machine and you allocate it only 1 GB, it will not be able to actually allow it. To say, no, we need a minimum of 2 GB. At the same time, you need more than 3 machines. But this virtual machine is not even going to use more than 1 GB at the time when it's running. But it requires a minimum of 2 GB to be installed on. So we can use memory over commitment to overcommit yourself. You're overcommitting yourself and saying, you know what, I know I have 2 GB, but I can go ahead and create 3 virtual machines, virtual machine 1, virtual machine 2, virtual machine 3, and assign each of them 2 GBs. I know in total, logically speaking, there will be 6 GBs, right? But on my machine, I only have 4 GB. But now this will allow you to install Linux because it meets the minimum requirements. Also, that one will allow you to install Linux because they meet the minimum requirements, or even let's say Windows. And this one will also allow you to install Windows. So we have installed Windows virtual machines, 3 of them, for the purposes we want. So we are saying that overcommitment allows us to use more memory than the total memory on our physical machine or server. It includes technologies like memory. Yes, please.
So in over memory commitment, does it mean you cannot allocate, for example, in this instance, the physical machine has 4 GB. Can I assign 6 GB to my virtual machine, or I don't have to give it beyond what the physical memory has? In this, I mean, is the virtual machine now thinking it is the only one running on the hypervisor? I don't know if you understood me.
I have not understood you, Romeo.
Okay. We have allocated 2 GB per virtual machine.
Yes, please.
Let us say I want to give my virtual machine 6 GB. Can I give it memory more than the memory on the physical machine?
You can
I allocate
memory
6 GB on any of those virtual machines?
You can give it memory more than the physical machine to improve on the virtual machine density. But you cannot use the memory you do not have. A virtual machine cannot use more than the available memory on the real hypervisor. Virtual machine density, like I've explained to you, for you to be able to run some services, like when you're installing some services, they require you to have a minimum requirements. Like let's say I'm installing Windows and it is requiring me to have 2 GB of memory at least. And I know I need 3 machines like here. So I can go ahead and overcommit myself. In total, I have given out 6 GB. Right? I've given out 6 GB, but I know I have only 4 GB. But all these machines are not going to use all the 6 GB. They can never use the 6 GB because you cannot use what you don't have, right? But let's say this virtual machine will just be consuming, let's say 1 GB. This guy is also consuming 1 GB, and this guy is maybe now consuming 2 GBs, right? So at the end of the day, I've overcommitted myself, but when it comes to the actual usage, one virtual machine cannot exceed the total number of physical resources you have available. Let me first explain the different modes, then you understand why we can even go ahead and overcommit and do memory overcommitment. So we are saying it has different technologies, and these technologies work at the same time. They need to be applied together and they take effect at the same time. So do not try to compare one with each other. One is the first one, which we are calling sharing. Oh, what has happened to my pen? Okay. One which we are calling sharing. And with sharing here, What it does, multiple virtual machines share the memory page on which the data content is the same. We have installed Windows operating system here. We have installed Windows operating system here, and also Windows operating system on virtual machine 1. So these guys, as you notice, as you run in Windows operating system, we have some services which are the same, right? Which are the same, and they're going to be on the same memory page. Let me try and go to taskbar, task view. Okay, did I go to settings instead? All right, I want to go to my taskbar. So I have my task manager. When I go to some of the processes that are running, you realize I'll have some process, regardless whether I'm on my computer or whether you're on your computer, some processes are for the operating system and they are going to be working like system local. These processes are taking memory and they're using memory, but they are of the operating system. So with memory sharing, what we are saying here, the virtual machines are going to get this process because this is a Windows virtual machine here. This guy is also a Windows virtual machine and also this guy. And we have some of the processes, they are the same. So what they're going to do, they're going to get and they are going to share the memory page on which the data content is the same and they're going to make it the same. So instead of having this guy, which would have used, I don't know how many memory, like this guy is using 5.4, it will be 5.4 across all the three. Across all the three virtual machines. Hereby, we are achieving memory sharing. That the content, like you are seeing here, some of this, let's say this is 1 GB, right? This content which is in a shared page is equal to 1 GB. Also, this is equal to 1 GB, right? Also, this is equal to 1 GB. But remember, it is the same. So they're going to store it in the same physical memory. So ideally, we have just used 1 GB and we still have 3 GBs left. And let's say the remainder here, this guy also has 1 GB. Now this makes 2 GB. And this guy is also using 1 GB. And now we have our total of 4 GB. So this is what we are calling memory sharing. They share the same content on the same page. Let us also look at memory ballooning. With memory ballooning, like we said, all these technologies work and take place at the same time. With memory ballooning, what happens? The system automatically reclaims the unused memory from a virtual machine and allocates it to other virtual machines to use. We have created these 3 virtual machines, virtual machine 1, virtual machine 2, virtual machine 3. And we have created them and assigned them each one of them 4 GBs. But this guy is idle and probably he's using only 20%, or maybe you just started it, it's even on a screensaver and it's not using anything. But this guy has used 70% of his, allocated 2 GB. So what happens that you're going to get some of this idle and give it or borrow it, balloon it to virtual machine 3 and virtual machine 2 to enable them even perform better. So what is going to happen, this idle, that was memory sharing. Now we're looking at memory ballooning. What is going to happen, this idle ballooning or this idle memory which is not being used by virtual machine 1 will be borrowed to virtual machine 2 and virtual machine 3. That is what we are calling memory ballooning. And should virtual machine 1 now need to use his resources, he will then go ahead and call them back. But to make sure memory over commitment even works well, there are some other quality of service features which you can embed on and use together with memory over commitment to achieve the best goal possible. And we are going to look at some of those things later on. So this is what you're calling memory ballooning. Let us also look at another feature here, which are calling memory swapping. What happens with memory swapping? The external storage is virtualized into memory for virtual machines for use. They're going to use some swap area in Linux. Usually they call it swap area. They're going to use some of that area, and in Windows sometimes it's called cache or a page file, depending on the operating system you're using. So they're going to get some from your hard drive, and they are going to virtualize it into memory for virtual machines to use. But it is going to be dealing with the data that is not temporarily it's going to, the data that is not used temporarily is stored on the external storage. So the data that is not being used is going to be stored on this area, on our storage devices. That is where the data is going to be stored. And if that data needs to be now reused, it is going to be exchanged with the data reserved on our memory. So we have our memory and they have reserved it. They are going to go ahead and create some partition because they know you open this file and it has been idle. It has been minimized for a very long time. Let's say the PowerPoint file or whatever file there is, and you have not been using it. What it's going to do, it's going to go ahead and put that file into your swap area, or it's going to virtualize some of your hard disk performance, and then it's going to keep and use that. And then when you need, like you see here, the virtual machine 3, it's the same virtual machine. We're giving an example on virtual machine 3 that is going to get some of the idle processes, some of the idle things, and keep them on that virtualized from our physical storage, from our storage, our hard disks, or the storage that is going to be keeping data. It's going to get some part of that, and it's going to keep on storing that information from our idle things. Like we have been using the processes here, we've opened it and it's in the background and it is idle for quite some time. What do we do now? You know what? Because we are not accessing that information currently, and we don't need to have high speed read and write. So let us just keep it in our swap area for a meantime. And then after, when we need it, and we need it now, maybe a user has gone ahead and clicked on the process, we will go ahead and reclaim it back into our reserved memory, and then now we can be able to use it. So that is what we call memory swapping. Yes, Moses.
I check. Is it one of the reasons why sometimes when you open a file on a computer, it takes some time without opening it? When you get back to it, it takes some time to resume or to start?
Most likely, yes. Keeping other factors constant, but most likely, yes.
Noted. Thank you.
All right. So this is what in total we have been looking at, and it's what we are calling memory over commitment. So we want to also now look at the virtualization features at the virtual machine level. We have been looking at the cluster level. Now I want to understand, okay, yes, we know when we are using clusters and we have put together different physical hosts to, give us benefits, we can use some of those things to, manage our virtualized environment. Now, what is the advantages? What are the benefits? What features do virtual machines provide to us? We want to look at some of those benefits. And the first one is what we are calling quick deployment. Like you told me already, one of the advantages to quickly deploy our virtual machines, that if I have a virtual machine, I can now quickly go ahead and deploy it within minutes, and I have a virtual machine. Let me just give you a scenario. You are the IT guy, and maybe you're an IT guy for some company, right? An IT guy for some company, and every week or after 2 months, they bring in two employees. They bring in, 20 new employees. And these 20 new employees, all you're supposed to create for them a machine on the network, and they use Windows 10, let's say. And on Windows 10, each machine, you go ahead and install the software. You install the antivirus, and you go ahead and install the software they'll be using, let's say software X. You also go ahead and install maybe the VPN you'll be using so that they are able to connect to some external resource. And then also you're able to go ahead and configure it on the network and then put there the policies on your domain, which could even be done by the Active Directory. And maybe you go ahead and also put there some documents that they need to access on every machine. And let's say this happens every week and you're not using a virtualized environment. So what happens here, every time these guys come, could you please mute your microphone, either Mulenga or Jara Emmanuel? Emmanuel? That is the last time I'm telling you to mute. The next time I'll just put you in the waiting room.
Mr. Cindy, sorry for the interruption. I just want to chip in something. You throw some light on it. what
please.
you're elaborating, is it like to domain? Is it called? I'm forgetting the term. There's a certain, okay, at times I was working in a bank, and every time you would get to office, you're given a machine, but you are given a name and a username. Whichever one, and input your username and the password, you find all your files on that desktop. Whichever machine you go to,
Migrating profile.
even when they change your branch, wherever you go, you would find it. Is it the same as this?
Someone has given you a response. Who was that?
The migrating profile.
Okay.
Thank you.
All right. So you have to create these new machines all the time. And it is quite hectic. You get updates, make updates, install the softwares on every machine. Let's say there were even 50 employees coming in. But we have virtualization, we are saying that through using some of the techniques like cloning, or the techniques like using a template, you can be able to create as many machines as possible within just a few clicks, and you have the machines. What happens? First, create your first machine, install your Windows, install your antivirus, all the software you need, and create your template. This is the template I have for all the new employees who are going to be coming through. This is their template. So you go ahead and create your template, and you're going to be using this template. Whenever they come, specify, I want 20, create your virtual machines within instantly. You don't have to wait for an operating system to install. Boom, the template is created and then the operating system is installed, and you can use it as many times as you want. This is what we are calling quick deployment. So with quick deployment, we can quickly deploy either by using templates or by cloning. And we're going to be looking at some of those things. With a template here, like you hear the word template. If you have a CP template, a Word template, help me with your Excel template, help me with your Word template. It is basically a structure of something that you want to, either copy or modify, or even add some things, or even remove other things. So a template is a copy of a virtual machine, and it contains the virtual machine disks and the configuration files. Creating a virtual machine using a virtual machine template can greatly reduce the time for configuring a new virtual machine and installing an operating system. So after a virtual machine template is created, it cannot be started or modified. So because it's a template, like you don't start it, you just create it and you'll be like, this is my template. I have created it and I'll be using it to create more machines. So the key things to note: it cannot be started or it cannot be modified. Once you have created it and converted it into a template, it cannot be started or it cannot be modified. And because it's just a template, it does not occupy any resources on your cluster. It is just a template. And a virtual machine deployed using a template is also independent of that template. Like whatever you do with this virtual machine, which was created from this template, has nothing to do with the template. All right. So to update or edit a template, one, you need to first convert it back into a virtual machine. You can convert it back into now a live virtual machine. Go ahead, change some parameters. Let's say the antivirus now is outdated, or you are using perhaps version 1 of the software you're using, and now you want to be installing version 2. So you go ahead and convert it into a virtual machine. Go ahead and install version 2 in a virtual machine when it's really running, and then you convert it back into a template, and then now you can use that template to go ahead and deploy other machines when the need arises. So then after template is edited only after you have converted it back into a virtual machine. And once you convert it back into a template, then you cannot be edited. Virtual machine templates are very useful for deploying a large number of similar virtual machines because it keeps virtual machine consistency, and the parameters can be modified automatically. You can just go and say, on this, let me modify the host name and SSI, and depending on what you want to achieve. And this is what we are calling a virtual machine template. So also you have another way of cloning, right? You have another way of cloning. It's also another way of quickly, sometimes they call it replication or replicating. It's another way of quickly deploying a virtual machine. So this function is called cloning, and it is different from template-based deployment. Cloning is basically a process of completely copying the source at a specific time. This virtual machine is running. At this particular time, I'll go ahead and clone and make a clone out of it, make a copy out of it the way it is. This virtual machine that at this particular time, if someone had stopped at doing what, put this document here or open VLC at this particular time, you clone it and then have a copy of that. This is what they call cloning. It's basically like you do copy and paste. So all settings of each cloned virtual machine, including the host IP, including the host name, are the same of that as the source virtual machine, because you have just copied it from that. The system will report an error if you try to start two of them at the same time. Why? Because there will be an IP conflict. This guy is having the same IP as this guy, also having the same host name as that guy. That means that there will be a conflict, and therefore you have to either first start one of them and modify the IP and depending on what need, or depending on the need that you have. So with template, like you can see, you have a template, you go ahead and create virtual machine 1, virtual machine 2, and you can even create as more as possible depending on the need that you have. This is what we call virtual machine deployment using a template. There's another one, we have virtual machine 1 here. We go ahead and make a copy out of it, and we can even copy these copies of this copy, and we can copy a particular machine at any time. We can copy and have virtual machine 2 from that copy. We can even make another copy. We can clone and have virtual machine 3. We can even make that clone and have virtual machine 4. So it's basically just copying that particular state of that machine with all its details. It's either called cloning sometimes, or sometimes it's called replication. So this is my Ubuntu. What was my password? What password did we set when we were creating it?
So it didn't show us.
Oh, I don't remember. Okay. What was my password?
You try Huawei.
Huawei at 123. Oh yeah, it could have been that, because I usually use that example for illustration purposes. Wow, it's not the one.
Capital H.
Capital H. I've tried that. Wow, how could I?
It wasn't that long. It was short.
It was short, eh?
Yeah, just about 5 letters, 5 keys if I recall.
Wow. You guys remember even the 5 characters? Okay.
How easy it is to be hacked, eh?
I know.
These guys are hackers.
We have hackers here.
Wow, guys are hackers, right?
I know, but I think I've got it. Only that it's taking long to begin.
Now
Wait.
you can share it, or you will still shall remind you that there are 5 characters.
No. I will delete the machine after, so no worries.
So you can share.
So no worries. So it is just starting, and I have my virtual machine. I had never opened it, started it, as I think it took some time to start. But this is my virtual machine. So I can even go ahead and go to my virtual machine settings, and I'm able to increase the resources. As you can see, I don't have even to power it off. I don't have to power it on, but though some changes, like the changes amount of memory, will take effect until the virtual machine is restarted, right? Some changes like memory, but as far as a disk is concerned, I could go ahead and create another disk and then go ahead and expand it. I can even go ahead and add other network adapters, add more resources depending on what I want to achieve, minus me having to power off my virtual machine. So I could go ahead and virtual, I don't know what's up with this. Okay.
So could you show us the templates? Can you do that with the VM workstation?
Yeah, I'm used to VM workstation. However, I'm using VM player and I'm trying to access access where I can create the snapshots and cloning it. But just a moment, let me just figure it out briefly. Just a moment. Where's VMware?
Maybe just a question whilst you're trying to open the virtual machine on
Yes,
cloning.
please.
This type of cloning that you talked about, is it the same one they use for like those who are doing audits whereby they can clone a hard drive and it will bring back all the deleted data? I don't know, is it the same one?
Yes, exactly. You're just cloning something from that state to how it was, and you clone or you clone that particular drive onto another one. So you have 2 copies of that drive, right?
Yeah.
Yes, exactly.
Okay, thank you.
Okay, what were we up to?
We're on the virtual machine. We wanted to clone it, I assume.
Oh, okay. We wanted to clone it. VMware workstation player. Let me open it. Okay, let me first move away from that. Virtual machine appears to be in use. Okay. I think because I'm using the player, I think that's why most, which is not updated to Pro. That's why I don't have the snapshot and creation options. But tomorrow before the next class, I'll be able to show you because I'm not seeing those settings there, but I should be able to see VM, and under virtual machine, I go ahead and either clone it or go ahead and take snapshots of that virtual machine. So tomorrow, when I open, when tomorrow, I'll make sure I reinstall VMware Workstation Pro, and then we shall use that. I'll just migrate these files onto VMware Workstation Pro, so I won't have to recreate this virtual machine again. So let me just keep it there running in the background, and we'll continue with our class. So we are looking at those features. So another feature is a resource hot add. I think I've already illustrated this, right? What do we mean by resource hot add?
Mic check.
Go ahead.
Yes, James. Now I think resource hot add is what we're doing. We add resources in real time when the machine is still operating, and we don't have to interrupt any service.
Perfectly well said. So here we just add resources like the compute, storage, network resources to a virtual machine, even when it is started, minus interrupting the resources. So in addition to just CPU or memory resources, or storage, network resources, you can CPU resources also support hot add, and also the storage resources support hot add. So you can expand, for example, the capacity of your network interface card. You can even add another network interface card onto your virtual machine. Hot add functions need to be supported by the virtual machine and also the operating system. That's why you saw some message saying that this particular kind of hot add will only take effect after when the machine is restarted. So, but in most cases, it's funny how many hypervisors and operating system and virtual machines support hot add, but they don't support hot remove. It's just like the example. You can do it, but it will be very, very painful. Just like when you go to the bank and you want to deposit your money. Sometimes they even won't ask you too many questions, but go there when you want to deposit money from the bank. That's when you need to present an ID. Who of you presents an ID when you're depositing money?
No one.
No one. Eh? They'll just receive your money with a big smile, right? And you add on to what you want. But when you want to remove it now, they'll ask you for your ID. They'll ask you to sign somewhere. And if your signature not matching, they'll even check your pictures and see. And yet they saw you previously when you're the actual guy who had actually deposited your money. So this is also the same analogy that works here. That's most of the virtual machines and operating system support easily to add things, but they do not support hot delete. You can easily expand a disk from 20 GB to 40 GB, but it is practically impossible, sometimes impossible, to reduce it from 40, let's say, to 30 GB when the virtual machine is running. Okay, so in terms of storage resource addition, you can expand the capacity of existing disks, and also you can add new disks to the virtual machine, but it is also extremely hard to hot delete. Please take note of that. You'll find that question quite a lot of trying to reduce the capacity of storages. So we can add resources. If our virtual machine is using almost 75%, we can go ahead and add more resources. At the end of the day, it becomes happy. This is what we are calling a hot add resources. Okay. So let us go to the next feature. The next feature is what you're calling a virtual machine console. And with a virtual machine console, basically, it is a way of how you can connect to a virtual machine. You all agree virtual machines have no monitors, right? Like our traditional computers, like your laptop. Your laptop has a monitor so you can access and manipulate its resources. So for you to be able to actually access the virtual machine, you actually have to first have some kind of console which you need to monitor and operate your virtual machine, minus actually being like the user of the virtual machine. So physical machines can be operated using monitors, but virtual machines cannot be. And once the network is disconnected, virtual machines may be controllable. A real-time virtual machine control technology is required if you want to be able to control the virtual machine. Most hardware devices that cannot be controlled or connected to a display system are configured with an independent management interface for users to perform management operations. For example, like many of the storage devices, switches, routers, they have some kind of console port which you can connect to them directly, and you're able to pass some parameters like increase the memory, like decrease the memory, do all those kinds of things. So in addition to these devices can be configured using the console interfaces. So also we're asking the same question, that can virtual machines be controlled using the same way? The answer is yes. We can also control virtual machines through a console port, and each vendor or each provider of the hypervisors provides the console management functions for virtual machines. For example, VMware uses what we call the remote console, and Huawei and KVM uses what we call the VNC. So the console is a network dependent, and it depends on the network. These consoles, VNC, is network dependent. And if you need to log into a virtual machine from a console, you do not necessarily have to give this virtual machine an IP address, but you need to configure the machine, because how will you access the machine which is connected to if you don't have an IP address to that machine? So you may need to configure the physical machine with an IP address where that virtual machine is located. So this is what we call console login. So you can log into a virtual machine using the console. Let us look at another feature which we're calling a snapshot. Someone in the chat had talked about a snapshot, and they're saying that in systems, a snapshot is a state of a system at a particular point in time. It can refer to an actual or copy state of a system or a capacity provided by systems. And he's extremely right. Even here, snapshots are meaning or referring to the same they refer to a virtual machine at a particular state in time, right? Point in time. When you take a snapshot of that virtual machine, it will be that virtual machine at that particular at that particular point in time. So in virtualization, virtual machine snapshots are similar to the snapshots you take on your screen. You have seen something and you want to take a snapshot of your conversation. So they're similar to even the pictures or the snapshots we take in real life. And a snapshot records the virtual machine status at a certain moment and contains complete data of that virtual machine at that particular moment. So you can use snapshots as a way to restore a virtual machine to a state, a specific time, in case maybe it becomes faulty or anything. You can always use a snapshot to restore your virtual machines. So this is what we are calling a snapshot. So they are stored on disks and they can be quickly accessed. And this helps us to accelerate and make sure that we have quick data restoration. They provide flexible and frequent restoration points for storage devices, and they can help us to restore, virtual machines to, different point in time. For example, let's say to restore also data that is accidentally erased or even damaged online. This is what you're calling snapshots. So we can do three things with snapshots. One is to create it, and we're going to look at it. We have our original virtual machine here. This is the time it was. We go ahead and take a snapshot. And after taking a snapshot of that, we have snapshot one. And now at this particular point in time, this is our snapshot one. And this will stay there as a snapshot and we'll be able to use. At this particular time, now we're going to read and write, data. This is like our new virtual machine, but we have this state unchanged. It has been kept for recovery. So we can also go ahead at this particular point in time and take another snapshot, and we have like snapshot two. And snapshot two, we are reading and writing data. But as you can see, this original state is not going to be changed. In case this virtual machine we are using and writing and reading data from at this particular time becomes faulty, we can always come back to this and restore. So we can create as many snapshots as possible. So the first way is to create. The second way, we have created a snapshot one, snapshot two. We can go ahead and we'll be like, this snapshot, it's just wasting our storage resources. We don't need it anymore. We can go ahead and delete it. So we can also delete snapshots. That is another way or something else we can do with a snapshot. And once you delete the snapshot, now you'll see that we are going to be reading and writing data. And this is what we are calling deleting a snapshot. So we only have two snapshots left there. The third one, which you are going to see here, in case our data becomes faulty, we have our snapshots, which we have created right here. And we want to restore this virtual machine, maybe point in time. So we are going to go ahead and restore our snapshot, and our virtual machine is going to be reverted back in time to when we took that particular snapshot at that particular time. So that is what we call restore. So there are three things. One, we can create a snapshot, we can delete a snapshot, and we can restore a virtual machine from a snapshot. So this is what we call a snapshot. So we also want to look at another concept here, one of the virtual machine features, and it is NUMA. NUMA is what we're calling the non-uniform memory access. With a non-uniform memory access, it is a technology that helps us to improve our data read and write speeds. So in modern times, the computing nodes of a single computer, they're not enough. Remember, as computers connect as our CPUs, in other terminologies, in computer sciences, people who did computer science will tell you that our CPUs and memory are connected through what we call they're interconnected through what we call the North Bridge. And I'm not going to get into the specifics. But as more resources are added onto the machine and more CPU, we are exhausting the speed or the read and write speed or functionality or capability of our North Bridge, thus having poor performance. So in a virtualized environment, they come up with the NUMA mode, and this NUMA mode basically just helps us to have some kind of non-uniform kind of way to access resources. Remember, this is remote access, and we're going to come up with a kind of virtual pools, which virtual pool is going to act as our resources, and it's going to help us to map our virtual machines which we have created. We are going to get memory from this pool and also allocate it to its north bridge remotely that is going to be attached to it. So this memory is going to be pulled from this, and also these at the same time, these are our physical resources in a non-uniform manner. So it's going to also be pulled from that resource, and this is acceptable because what we are using the non-uniform memory access to improve on our speed and write resources. Traditionally, as you can see, what they're not going to accept, you getting memory and getting CPU resources and memory from this pool and adding it. If you didn't have memory resource allocation or NUMA installed, this is not going to be allowed. That to get the virtual resource pool that is put in our remote access and also get our local access of our memory and then allocate it and assign it just like you have seen to one virtual machine and do the same there, that is not going to be allowed. But basically what you can pick out of NUMA is NUMA helps us to improve on our data, read and write speeds. Basically, that's what you should pick out of that. So we also wanted to look at the introduction to the features of Huawei virtualization products. We want to understand what are some of those features that Huawei virtualization products give us. What is the Huawei's virtualization product? We have been talking about it. Anyone?
Fusion Sphere.
Fusion Sphere, all fusion compute. So even when you meet questions and they are telling you in fusion compute, ideally they're even telling you in virtualization. So do not get so much confused and you be like, oh, what is this now? What is fusion compute, right? So when you say fusion compute, in Fusion Sphere, we are basically referring to the virtualization product and what does it do. So let us look at some of these virtualization tools or features that they have. As an advanced virtualization product, Fusion Compute not only supports the cluster and virtual machine features that we have talked about before, but it also provides us with enhanced general virtualization features. And to use all the features supported by Fusion Compute, you need to install the tools on our virtual machines. You saw me installing guest tools, virtual machine tools on VMware. Some VirtualBox calls them guest tools, VMware calls them VMware tools, and here in Huawei Fusion Compute, we are calling them. We need to install tools on our virtual machines. So these are some of the tools. Some of them work at kernel model drivers, and some of them work in user VM agent process. So I need hardware information. We look at the kernel model hardware drivers. I need virtual machine status. We look at the user mode virtual machine agent process. Basically, these tools are going to help us create snapshots, manage live migration, do online virtual machine flavor change, and also do network interface card quality of service. When we want to obtain the information about the virtual machines, we are going to use this process to obtain the virtual machine MAC address, see the status, whether it's up or down, also to do a soft shutdown, and also to restart the virtual machine if there is need. So these are some of the features. Let us look at them. It has both cluster features and it also has both cluster features and virtual machine features. So let us look at some of the cluster features. Many of these features, we have looked at them and we have seen them already, like high availability. What does high availability do? Anyone to tell us? Mic check, and go ahead and tell us.
Mic check.
Go ahead.
It supports multiple high availability policies, something like that.
Okay. By doing what exactly?
Mic check.
Go ahead, Kwezi.
It enables the servers, the host to switch in case of a host failure. Let's say a host server fails, it enables other servers to pick up the VMs that were running on that host that failed immediately.
Okay, thank you. All right, so we have talked about it, and we're going to also mention a few things. We also looked at the basic features like memory over commitment. We said there are 3 things in memory over commitment, right? What was that and what?
Memory sharing, ballooning, and swapping.
Ballooning and swapping. True or false? Tell me. You can use more than the available memory on a physical virtual machines can use more than available memory on a physical host. True or false?
False.
False. False.
Someone is saying. Someone is saying
Use is false.
Yes.
Allocate.
You can assign more than available memory, but it will not use more than the available memory.
Very good. You can allocate, but it cannot use more than. You need to be very mindful of those terms. You can allocate more than available memory, but virtual machines cannot use more than the available. I mean, what will it use if the resources are not available? So we also looked at overcommitment, and we also looked at some of the load balancing. We looked at load balancing, but we're also going to look at more other features that are given to you by like resource rescheduling, power management, and distribution rules here. We are going to be looking at them later on. We are also going to look at IMC and try to understand what it does. So let us look at high availability, which has CNA. CNA, remember, we are referring to what?
A host.
Node.
Yes, a host or node or physical server or whatever in a cluster, right? That is what we are referring to. So in case there's a host failure, in case there's data store failure, in case there's a blue screen of death, and only on Windows virtual machines. So let us look at high availability, but we're going to go through it just briefly because we have already looked at it. We are saying in Fusion Compute, clusters support multiple high availability policies. So you can go ahead and configure your policies here. And you'll be like, when this happens, please do this. When this happens, also go ahead and do that. So let us look at host failure. When there is host failure and the host has become faulty, we have 2 things we can do. Either we can choose to restore on original host after it has, you restart the host and then you restore it on the original host, or you can now choose to trigger virtual machine high availability. With restore on virtual machine original host, the hosts accommodating the virtual machine is hosted, then the system restarts. The virtual machine only starts or is restored after the host is restarted. So this is high availability policy when the host is faulty. So we also have another policy where the data store is usually where you shall look at it. I'll do some brief demo of the labs because I don't think we are going to get the lab environments before the exam. In case we do, well and good. If we don't, we shall just have to bear with what is available. So in case the data store here, data store is faulty and it is an issue, we can choose to either do nothing or we can choose to trigger high availability. So you are advised to select no action in most cases if the parameter is set to no action and the database default fault exceeds the value of the policy. And then or you can choose to do high availability. So in case the data store is faulty, then you can choose to do high availability and then your virtual machine will be migrated onto another host or CNA on the system. Then on Windows virtual machines, when the virtual machine itself, or even if it's not a Windows virtual machine and the virtual machine itself is faulty, what do? You can choose either to set no action, like do nothing, or you can first restart the virtual machine and see what happens, or you can even do a virtual machine high availability policy to, to migrate it onto another host. So when you configure high availability policy, only the Windows virtual machine blue screen of death handling policy supports virtual machine faults. Only the Windows blue screen blue screen of death supports the virtual machine fault policy in Fusion Compute, I think from 3.3 onwards. So this is what you're calling high availability. We looked at it later on. Now, let us look at another concept, which are calling distributed power management, the DPM. Yes, please.
Why would one just choose to do nothing? Are they is the virtual machine not important enough, or is it low priority, or what? Why would one, if you were using it and you needed it, why would you put a policy to do nothing in that case? Just clarity.
Thank you for that. Like you have asked all those questions, they would actually apply to the answer I would give you. It entirely depends on what you want to achieve. It entirely depends on the scenario for you as a network engineer. It could be that the virtual machine is doing something, but regularly not required to be on at almost all the time. But also, it could be you have to set to do nothing for you to be able to troubleshoot and find out what exactly is a problem. Yes, the virtual machine is faulty, it's not running. Before even it's migrated, you want to be able to try and find out what exactly brought the cause. Why is it off? Why is it faulty? And how best can I repair it? So it entirely depends on what you want to achieve and the circumstances at play. So we have another one, which is distributed power management, the DPM, and it enables a system to periodically check resource usage on hosts in a cluster. And if resources in a cluster are sufficient, but the load on each host is light, then the system will migrate the virtual machines to hosts and then powers off these hosts to reduce on power consumption. We have an example here. We want to be able to manage our power. We have our data center, right? And we have our cluster. We have so many servers running. But at night, usually people come onto our network services from about maybe 7 a.m. to 9 p.m. And from about 10 p.m. to 6 a.m., there is no traffic on most of our machines. I mean, we are powering them on and they are running and they are consuming our power. You know, we are meeting our maintenance costs and all that. Isn't it beautiful if there's a way we can automatically, get to see how best we can migrate some of the virtual machines from those servers which are not being used all to only the servers that we want to be on, power off these guys, and then after, when the load comes back on and the load is a lot, then we can migrate back and power them on and migrate back our virtual machines. So this is what you're calling power management. Like you can see in this example, at around 23 a.m., here around 7 a.m. up to 23, that is like 11 p.m., the load is quite, the people are occupying the virtual machines and the load is quite heavy. But after 23, like after 11 p.m., the load is not a lot. So what we do, we migrate these virtual machines. Probably they're even not being accessed or the users are asleep and they're not using the resources on our network. So we're going to migrate them and put them on these, CNA nodes, all our physical servers, and they can afford to have them because they're not really using them. They can afford to have those, machines and keep them running. And then why don't we go ahead and decide to power off these guys and switch them off so that we save on power consumption. And after saving on power consumption, and then time will fly by, and then the next day in the morning, we know users are going to come in and start accessing resources, and these guys will not be able to handle alone. We go ahead and power on these guys back up. We power them back on so that, wake up, we have work for you, and then remigrate the virtual machines back to them. This is what you're calling distributed power management. And you can configure policies and set policies to make sure that whenever those virtual machines are not, there's lightweight in your cluster, some of the virtual machines are powered off, and when the load is coming back or during to a given time, depending on how you configured it, they are powered back on. So as they are migrating now, we also need to keep some things into consideration. How do we make sure that this virtual machine is migrated to what physical host, to what physical host? And how do we make sure that there's reliability, that if you have redundancy, let's say it's our backup server, that they're not all on the same host, which could die at the same time? How do we make sure that these guys are, whenever they are migrating, they never go together? This one has to go his way, and also this one has to go this way. There's what we call the distributed resource scheduling rules that we can put there, which we are calling the DRS rules, the distributed resource scheduling rules. So both DRS and DPM, which we have just looked at, are part of load balancing. They're all helping us to manage and to, to balance our load and to share it evenly across different nodes. So these rules provide a reference for system migration during load balancing. When I am migrating this virtual machine, what should I keep into consideration? And we have the first mode, the keep virtual machines together mode. Now, the keep virtual machines together mode is, let's say, I'm just giving an example. This is our application, server, and this is our database server. And for some reason, because we want these guys to interchangeably share data and maybe on the same things, we always want them to be together. So we can configure the keep the virtual machines together, right? So even when they are migrating, this guy becomes faulty, or during whatever peak, as these guys are migrating, this guy, once he leaves and goes, and like, you know what, they told us to keep together. Once virtual machine 1 goes, then also virtual machine 2 will be forced to follow. They will be migrated together because you have configured the rule of keep these kinds of virtual machines together depending on what you want to achieve. Even when they migrate together. You always make sure, or they make sure they're on the same CNA node at that particular time. And this is what we call keep. The selected virtual machines always running on the same hosts. But here only one virtual machine can be added to one keep virtual machines together rule. You cannot add this guy also to this guy rule and you create another rule and you say keep together. Then this guy will be confused. Who should I go with? That's why they can only be added to one keep together rule. Okay, so another rule here, what we're looking at is a keep keep apart. Yes, please.
So are you trying to say in keep virtual machines together, there must only be 2 machines?
They can be 3, they can be 4, but you configure this group and you say, I'm giving you a role keep together. Whenever this guy moves, also this one will move, also that, and also that. We are just using 2 to just illustrate, but there could be any number depending on what you want to achieve.
But you cannot put, let's say, virtual machine 2. Is it because they are on different physical servers?
I was saying that only one virtual machine can be added to one group rule, to one distributed resource rule of keep together. Does that make sense?
I get it.
You cannot add it to more than 2 rules because then it will be confused. Who does it go with?
Understood.
You get it now, eh?
Yes.
Okay, so we are now looking at keep virtual machines apart. For some reason, you want these virtual machines to stay apart and never to be together, like poles of the same. How do they say?
Of the same feather flock together.
Okay, was it that? I was trying to mean something with the repairing and,
like charges repair.
Like poles repair.
Okay, like poles repair. So we also use this analogy. We want to keep these virtual machines apart. Let's say this is our backup server, right? And also this is our backup server. We want to, make sure our data is backed up. But we don't want these guys to ever be on the same physical machine. What if the physical machine dies and they were both on the same physical machine at the same time and we can't recover our backup data? Or let's say this is our application data, right? Our application server, I think this will make a lot of sense. And this is our backup, our application data backup. We don't want them to be on the same server. What if it gets corrupted at the same time, and even our backup gets corrupted at the same time. So we want these guys to always be on different hosts at different times. So when this guy migrates, because maybe this host is off, or maybe it's because during distributed power management, and he migrates and he comes by any rack to this virtual machine where this guy is, like poles, they're going to do what?
Repel.
They're going to repel each other. This guy will be forced to migrate automatically and move away from that guy. This guy is big-headed, comes back, and then it will be automatically migrated away. So they will always at all times keep away from each other. So this keeps the selected virtual machines running on different hosts, and only one virtual machine can be added to one virtual machine can be added to only one virtual machine, mutually exclusive, or keep apart role group. Okay, so let us look also to bound virtual machine to hosts. It's a third one. With a bounding virtual machine to hosts, this rule associates a group of virtual machines with a host group so that the virtual machines in a specified virtual machine group can be configured to only run on specific hosts in the host group. Let's say maybe for you in your a cluster, you have also other machines here, but only this cluster, you have attached maybe external devices they need. Like let's say you have attached the external USBs and everything they need, and those clusters are the ones that have the external supporting hardware for this virtual machine. So you configure bound to this group of hosts, that whenever you're migrating, do not go here, do not go anywhere else. Whatever host you must migrate to must be within this group of hosts. So you are bounding that group to a particular group, that whenever it migrates, it only goes to the host of groups which you have configured on the network. And now we want to look at IMC. IMC on Fusion Compute is the incompatible migration cluster. Like you hear the word incompatible migration cluster. So on Fusion Compute, enabling incompatible migration cluster mode for cluster allows virtual machines to migrate between the hosts that are using CPUs with different performance baselines within the cluster. As you notice, you can have different servers, server A, server B, and server C. But server A here is maybe, let's say, i5 generation 6. This one is i3 generation 8. This one is i5 generation, let's say 10. Okay, these are different now performance baselines for these CPUs. So if you enable IMC, it's going to allow virtual machines to migrate between hosts that are using different CPUs with different performance baselines within the cluster. Currently, the IMC mode only allows virtual machine live migration between hosts using Intel CPUs. Please take note of that. Currently, only Intel CPUs are allowed or are supported. So IMC mode allows the hosts in a cluster to present the same CPU function set to virtual machines running on them, despite the fact that these hosts can be using CPUs with different performance baselines. For the IMC mode to work for a cluster that already contains hosts and virtual machines, ensure that the following conditions are met. The first condition, the CPU generation of the host in a cluster are the same or later than the target IMC mode. The generation of the hosts in that cluster, they're either the same or later the target IMC mode. 2, the CPU generation of the running or hibernating virtual machines in a cluster are the same as or early than the target IMC mode. And if any virtual machine in a cluster does not meet this requirement, stop the virtual machine or migrate it onto another cluster if the virtual machine doesn't support that requirement. So basically what IMC does, it helps us to be able to migrate virtual machines from one CPU performance host to another, thus eliminating the incompatibility of compatibility support of different virtual machines and different CPUs with different performance baselines or generations. So let us look at the virtual machine futures. The virtual machine futures, we have looked at some of them. We have looked at resource management. We are going to look at CPU quality of service, memory quality of service, disk scaling, adding or deleting network interface cards, VNC login. We have looked at it or almost. We are going to look at, we have looked at fast deployment, VM deployment using a template or cloning. We have also looked at snapshots, bundling or attaching USB or PCI or GPU devices or CD-ROMs. We have looked at some of these features before. So let us look at CPU and memory quality of service. We start with memory, we start with CPU.
Mic check.
Go ahead.
Sandy, I'm taking you back to the previous slide. The
Okay.
other advantage, I think, of the previous slide again. Yes, here. I'm thinking the other advantage of IMC is, for example, I could be having a virtual machine running Android Studio, and other virtual machines CPU does not meet the quality or the requirements of Android Studio to run on it. So if this rule is not set, then one virtual machine will be migrated from this to the other one, which does not support it, and the application will crash or will not be able to run. I hope I'm right, or you can
You are right,
me.
200%. And I'm happy that you got the concept and you can even apply knowledge why we need such kind of functionality in our virtualization products. Okay, we're looking at memory and CPU quality of service. I was asking, which one should we start with?
CPU.
CPU. Why CPU?
CPU.
More interesting.
Because it's the one on the left or the right.
It's on the left.
Okay.
And you have both left, right.
More interesting, sir.
Okay, we'll start with CPU, but I'll only explain one, and it's the same concept across. It has three things: quota, reserved, and limit, and we're going to look at them briefly. So CPU quality of service ensures optimal allocation of compute resources for virtual machines and also prevents resource competition between virtual machines due to different service requirements. Because when virtual machines are started and there are applications that are, asking, demanding for resources, if you have not configured your quality of service very well, you may also have issues as far as resource utilization is concerned. So we can use CPU quality of service to effectively increase resource utilization and also reduce on the costs. So during creation of virtual machines, the CPU's quality of service is specified basing on the services to be deployed, depending on what you want to achieve. You know that this virtual machine A, you have three virtual machines. You have virtual machine 1, you have virtual machine 2, you have also virtual machine 3. And you know that virtual machine 1 is not really very needed, and you know that virtual machine 2 is your priority virtual machine because it's going to be running, let's say, your core services, and let's say virtual machine 3 is going to be running your backup services, right? So when you're even applying your quality of services, you deploy them basing on the services that you're going to put there. So the CPU quality of services determines the computing capabilities, and the system ensures the CPU quality of service of machines by ensuring the minimum resources and resource allocation priority. So we are going to look at them, and we're going to start with quota. Like you hear the word quota, it is just a proportion of what they're going to give you. So quota defines the proportion based on which CPU resources to be allocated to each virtual machine when virtual machines compete for the physical resources. The keyword is compete. Under normal circumstances, when these guys are not competing and you have allocated 2 GB here, you have allocated 2 GB, and you have allocated 2 GB, and they're not competing, right? For maybe, for instance, virtual machine 3 here is off and is not using his resources, and also this guy is using like also 20%. This guy can go ahead and utilize and use all the 2 GBs that you have allocated him, because they are not competing for resources. But should they be all powered on, and maybe users have opened applications here and they are using them and they're accessing resources, then this is when the memory or CPU quality of service, in this case we're looking at CPU, comes into play. And now we look at the quota rule which we have specified. So here it will be on quota basis, or you can even use percentages or ratio kind of basis. You're going to say that, you know what, I only have 4 GB allocated on my hypervisor. But in case these guys are competing for resources, I am going to use a ratio of 1 to 2 to 1. Why? Because virtual machine 1, I don't have so many core services running on it. Virtual machine 2 here, I have quite a number. It is running my core services. So I want it to have the maximum, resources whenever these guys are competing for resources. And this guy should have, should also have 1. In percentages, this could be 25 to 50 to 25, right? So this guy would take about 50% of the memory, this guy about 25, and this guy about 25. In case, and the keyword is this, all these guys are competing for resources. So if we are using this ratio, what GB, if these guys were competing, virtual machine 1 will have how many gigahertz allocated to him. Let's say we had our processors with 4 cores, right? With 4 cores, how many cores would be allocated to virtual machine 1?
1.
It would be 1. How about virtual machine 2?
2 cores.
And virtual machine 3?
1.
1 core. All right. So that would be it. But if they are not competing for the resources, this guy, it is okay. They can all go ahead and enjoy and utilize all the resources. So CPU quota takes effect only when resource contention occurs among virtual machines. They are, saying, no, I should be the one using this. No, I want to use all my 2 GBs that are allocated to me. Okay, I also want to use my 2 GBs. Then, okay, we all want to use our 2 GBs. What does the quality of service rule say? Oh, it says actually, this guy is given priority, so he's going to use go ahead and use the 2 GB. Then me, according to my quota, whenever I are competing for resources, I use this kind of percentage. So let me use that. So that is quality of service. 1, to enable us to maximize resource utilization. 2, also to enable us to reduce on costs. So if the CPU resources are sufficient, like I've told you, then the virtual machines can exclusively use the physical resources available on the host if required. So if these guys are idle, like virtual machine 2 and 3, virtual machine 1 can go ahead and use all the resources, the 2 GBs which you have allocated to him. And only this quota comes into play only and only when they are now all fighting for the same resources. Let us go to CPU reservation, or what some people call reserved. So when you go to CPU reservation, this looks at the minimum. It looks at the minimum, and it defines the minimum CPU resources to be allocated to each virtual machine when multiple virtual machines compete for the physical or for the same physical CPU resources. So here it defines the minimum that at any given time, virtual machine 1 and virtual machine look at me and hear me out. Whenever you guys are competing for resources, because this guy is having my core services, at any worst moment, this guy should always have a minimum of 2 GB allocated to him. Why? Because I know that the resources he needs to use are quite heavy for him. And this guy may be, because he's just using, you know, and we need him to work maybe at a given time, and it's not very important, maybe the minimum he can use is 0.5, right? So whenever these guys are competing for resources, then this guy will have like 0.5 cores. This guy will have 2 cores. So I forget, and I think I'm explaining memory. This guy will have 2 cores, and then this guy will have how many cores? 1 cores. So because the minimum, as long as they start, you know, bargaining and debating and competing for resources, then this guy will come into place, and then he will be able to take over the memory, the CPU reservation. So it looks at the minimum kind of resources that are supposed to be allocated to the CPU. So looking at the last one, which is limits. With limits, it basically defines the maximum CPU resources to be allocated per virtual machine. It defines the upper limit, right? It defines the upper limit, and it defines the upper limit of physical CPUs that can be used by a virtual machine. And if a virtual machine with 2 CPUs has a limit of 3 gigahertz, then each virtual machine cannot obtain a maximum of 1.5 gigahertz compute resources. So what I'm saying, what they were trying to explain there is that it explains the maximum. Like this virtual machines here, we want to set upper limits. I know they all agree, and sometimes they may want to consume all the resources on our physical resources. But at any given moment, because I know also I need to leave out some memory, let's say I need to leave out 1 GB for my, I need to leave out 1 core for my physical CPU, for my physical hypervisor to use. 1 core is supposed to be reserved for that, meaning I have a balance of 3 cores to use across my machines. So I go ahead and specify, but this guy is running my core, my major function. So I'll go ahead and specify, and I say, okay, you know what? This guy will use 2 cores at any one given moment. This is his maximum. He cannot go above that and accesses 3 or 4. His maximum is 2 cores, and this guy here is going to use 0.5, and then this guy will use 0.5. What would be the total? The total here would be 3 cores, and then also my core here reserved, making a total of 4 cores reserved for my hypervisor. So I go and I set an upper limit, and I say, you guys, whenever you're competing for resources, please do not exceed these kinds of resources. And in case they're not competing, maybe this guy is idle or off, this guy can go ahead, because these guys are off and not idle, he can go ahead and enjoy the 3 cores to himself. But when they come back and all are competing for resources, then that is when the memory, the CPU limit quality of service comes into play. And the same explanation applies for memory. Let me hear someone explain for me memory quota.
Hello.
Yes, please. Go ahead.
Memory quota. This is the share that is given, the share of memory that is given to a virtual machine in case if there is competition for resources.
Yes, keyword, in case there is competition for resources. Okay. So if I had my hypervisor and I give it a hypervisor of 6 GB RAM, right? And I have my virtual machine 1, 2, and virtual machine 3, and I give it a ratio of, let me say, I give it a ratio of 50 to 25 to 25. How much would virtual machine 1, how much memory would virtual machine 1 be allocated?
Should have 3 GB.
3 GB.
3 GB. And virtual machine 2?
1.5.
1.5.
1.5 and virtual machine 3?
1.5.
1.5 as well.
1.5.
1.5.
Okay. Could also someone explain to me as memory limit?
Check.
Go ahead.
I think this is the maximum amount of memory that any of the virtual machines can acquire in the event of scramble for resources.
Yes, it explains the maximum maximum memory which can be allocated to those different given virtual machines when there's competition for resources. Okay, but in case there's no competition for resources, the virtual machines will go ahead and enjoy. Someone to explain reserved?
It is a fixed amount of memory allocated to a virtual machine, even when there is scramble of during the scramble of resources. Let's say if you have virtual machine 1, 2, 3, and you have reserved virtual machine 2 to be having 50 in a ratio of 1:1. So virtual machine 2 will always have 50, and then the rest will be distributed among the other machines.
Okay, thank you, Romeo. The key word is minimum.
It reserves the minimum.
Yes, that whenever they are competing for resources, never go below, let's say, 3 GB, right? Even if they convince you to give them as many GBs as they want, even if it's just 1 MB out of this 3, please never go below 3 GB. Okay, so there's also what they call network quality of service. This content does not really talk much about it, but it's a network policy that controls the bandwidth configurations. Network quality of service is determined by the bandwidth control based on the sending and receiving direction of port group numbers, and also it looks at traffic shaping and bandwidth priority. Basically, to see which port should we send first, what should we give priority. Basically, it looks at the network, and it's what we're calling the network quality of service. Quick question. Which of the following is not a snapshot management option? Which of the following is not a snapshot management option? And the question is multi-choice.
T. Modify and replicate.
G.
Multi-choice, yes, please.
A, the answer is B and D.
The answer is B and D. We said we can restore virtual machines using snapshots. We said we can create snapshots. We can also do what?
Delete.
We can also delete. Yeah, but in sometimes if the question is single choice, right? You only select modify snapshot. Some people can copy snapshots, but it is pointless. Why would you copy a snapshot of something? But some people can replicate or copy a snapshot. If it is single choice, but if it is multi-choice, please, the answers are those ones, like you have stated. Thank you. So templates can be used to quickly deploy virtual machines. At present, templates can be created only by converting or cloning virtual machines. True or false? Give me your answer and tell me why.
True.
Why?
You can create a template by converting it from virtual machine, but you cannot modify it unless you convert it back to a virtual machine.
So you are saying the answer is what?
True.
Okay, you're saying the answer is true. And you're saying because?
Create a template from a virtual machine, and you can also create a virtual machine from a template, but you cannot modify the template.
Okay, anyone with a divergent view? Thank you. All of you are not yeah, here.
So I think false. So I
Why?
think false.
Why do you think it's false?
Because templates are not made by cloning. They usually are made by converting, I think. So yeah, that's why I think it's false.
When you are cloning virtual machines, you are actually not making templates, right? You're just creating another virtual machine when you're replicating a virtual machine. The only way we create templates is by converting them, right? You create a virtual machine and convert it into a template, which template cannot be modified. And if you want to modify it, like our friend told us, you have to first convert it back to a virtual machine. That's why I keep writing W, to a virtual machine. And after converting it back to a virtual machine, then this is when you can now modify it, change things, and then you after convert it back into a template, right? So what makes this statement false here, which is telling us that templates can be used to quickly deploy virtual machines. This is 100% correct, right? And they say at present, templates can be created only by converting. Converting is true. When they say cloning, then this one makes the entire statement false. So our answer would be false. Are we together?
Yes.
Okay, so we have looked at we have tried to understand virtualization features and also understand where and when virtualization features may be used. These are some of the recommended material. You can go ahead and look out for them. And this brings us to the end of this lecture. And for more resources, you can visit www.huawei.com.